So now, some things can happen with interference, some different kind of phenomenon, and one of those phenomenon is this idea of beading. So beading is when you have two waves of slightly different frequency. The interference pattern is one of constructive and destructive interference. Okay? So there is an interference pattern of constructive and destructive interference. So what I mean by that is there's a pattern where all of a sudden they will interfere constructively, and then a little bit of time goes on and they're going to interfere destructively, and then a little bit of time goes on and they interfere constructively, and the pattern repeats. So the best example of beading is actually not with waves, but with an oscillation, and that is with like car signals. So if you've ever been like at a stoplight and you're going to turn left, and you have your blinker on, and the car in front of you has their blinker on, but their blinker frequency is a little bit different than your blinker frequency, and so there's this point where both your blinker and the car in front of you's blinker, they blink at the same time, and then they kind of get off, and so they're out of phase with each other, and then all of a sudden your blinker is blinking and theirs is exactly not blinking. That would be like destructive interference. And then they're kind of this combination and they both blink at the same time. That's constructive interference. And then they are off. And then they both blink. And they're off. And they both blink. That's a pattern of beading. Okay, where you have constructive interference, destructive interference. Constructive interference, destructive interference. And when we get back into class, I will show you an example of this, both visually and with a sound wave. Because we tend to notice it quite a bit with sound waves if the two frequencies are just a little tiniest bit off. But with beating, there's something called the beat frequency. And the beat frequency is the rate at which this pattern occurs. So what is the rate at which you see the constructive, destructive interference? And the beat frequency is just going to be the absolute value of the difference in frequencies. So if I have two sound waves and one is 400 hertz and one is 399 hertz, then the beat frequency would just be 1 hertz. And that means that 1 hertz, that once per second, is I would hear that constructive, destructive interference happen 1 time per second. And again, I'll do this example in class.
Okay, so this simulation is going to allow me to show you how waves are going to interfere with each other. So I'm going to turn on wave A. So wave A has a frequency of 300 hertz, and you can see from the oscilloscope that it's got an amplitude of, I don't know, about 0.9, 0.85-ish, I guess, up there. And we can see the wave pattern. I can turn on wave B, and it's right on top of wave A because they're the exact same frequency. I can turn this off. Here. They're just right on top of each other, okay? This button would allow me to see the sum. So right now, look at what the amplitude is. If I were to show the sum of them, they should constructively interfere with each other because they have the exact same frequency. And so you can kind of see the scale shifted. This green one is my wave B, and blue is the sum of my waves. And you could see, oh, the amplitude just doubled, which makes sense because they are the exact same waves. And if I were to turn on the sound, we would just hear a loud sound. So that is just the interference pattern of two waves, both at 300 hertz. Okay? Now, beating is the idea of when you have two waves and they have slightly different frequencies. We're going to have an interference pattern. So I'm going to change this to 301. And I should have a beat frequency of 1 hertz, meaning 1 time per second, I should see constructive and destructive interference. And if I look at just my two waves individually, here's my wave A by itself. And then if I add on wave B, we can see they're not on top of each other anymore. Like there's a slight delay as we get further and further away. And so in terms of the sum, when I'm looking at the sum of these two waves, it doesn't really look like there's much of an interference pattern, but I'm going to zoom out a bit. There you can see it. We've got the constructive interference, and then it begins to destructively interfere. And then there's one point in time right here where we have completely destructive interference. and then we go back up here to have the constructive interference. So that takes 1 second for that to happen, for them to have constructive, destructive, back up to constructive. So visually we can see the beat pattern. If we listen to it, we should be able to hear it as well. So we hear the constructive and destructive interference 1 time every second. Okay? And that's, again, beat frequency is just a difference in frequencies. So if I increase this and change this to 300 and I'll say 4, my beat frequency would now be 4. So it's saying 4 times in a second, I should see the constructive destructive interference pattern, and I should hear the constructive destructive interference pattern. So there's the visual. Okay, from here, I have it happen once, twice, 3 times, 4 times. So that constructive destructive interference pattern happens 4 times in 1 second. And if I listen to it, I should be able to hear that as well. Okay. And you could increase it even more and hear it again. And there gets to be a point where your brain no longer recognizes the differences in frequencies and just thinks it's a new tone added up. So beat frequency really is audible when you have just a slight difference in the frequencies of the 2 notes that are being played.